This is lesson 6.2, Substitution. Your objectives are to solve systems of equations by using substitution and to solve real-world problems involving systems of equations by using substitution. When you solve with substitution, you're doing it algebraically. First, find a variable with coefficient 1, and then solve that equation for that variable. Take the result and substitute it into the other equation, and solve the other equation. This will give you a variable and an actual value for that variable. Take that number and substitute it into either equation. If you put it in the result of step 2, that's the easiest place to do it. Solve that and then write the final answer. One thing to keep in mind, while you're doing the work, if the variables disappear and cancel out while you're solving, and the result is true, you have infinitely many solutions. If the result is false, there's no solution. Remember, there are 3 possibilities for a system. There could be one solution, and that's what happens most of the time. But they could also be overlapping lines with infinitely many solutions, or parallel lines with no solution. So keep that in mind when those 2 other situations occur. Use substitution to solve each system of equations. Number 1. Y equals 4x and 3x minus y equals 1. To solve by substitution, first find a variable with coefficient 1. And there's 2 choices, the y in the first equation and the y in the second equation. Now we pick one of those to use. Let's use the y in the first equation. And we'll solve for that variable. Well, in y equals 4x, it's already solved for y, so we don't have to do that work here. Now, substitute whatever y is into the other equation. The other equation is 3x minus y equals 1. So we're going to take 4x, which is what y is, and substitute it in for y in the second equation. 3x minus, put a 4x where the y was, equals 1. Now solve that equation. 3x minus 4x is negative x. And if negative x equals 1, we'll divide both sides by negative 1, and x is negative 1. Now that I know what x is, let's substitute that into either equation, and the easiest one to use will be the y equals 4x. Whichever one you solve for the variable to start with, that's the best choice to use. Y equals 4x, and x is going to be negative 1. So y equals 4 times negative 1, which is negative 4. I now have an x and a y. My answer will be the ordered pair negative 1, negative 4. This is like 2 lines that intersect at the point negative 1, negative 4. Number 2, x equals 2y and y equals x minus 2. For substitution, start by finding a variable with coefficient 1. And we have 3 choices, the x, the y, and the x. Select one of those to solve for. You got several choices. Let's use the first one. X equals 2y. We would solve that for x, but on this one it's already solved for x, so we can move on to the next step, which is substitute that into the other equation. So, since x equals 2y, we'll substitute a 2y in for x in the other equation. Y equals 2y minus 2. I just substituted 2y in for x in the other equation. Now solve that equation. Get the y's on the same side. We can move them to the left by subtracting 2y from each side. On the left, y minus 2y is negative y. On the right, the two y's cancel and leave negative 2. We can divide both sides by -1, and y is +2. Now take that and substitute it into any equation, and the easiest one is the one that we solved for at the beginning, which is x equals 2y. We just found out that y is 2, so let's substitute a 2 in for the y. X equals 2 times 2, which is 4. So the answer is the ordered pair 4, 2. This is like two lines that intersect at one point, and that point is 4, 2. Number 4, x minus 2y equals -1, and 3y equals x plus 4. When you solve by substitution, you start by finding a variable with coefficient 1, and we have the x in the first equation and the x in the second equation. Choose one of those and solve for it. Let's use the first one. And we'll solve for the x. Since 2y is being subtracted, we'll do the opposite and add 2y to each side. The 2y's cancel on the left, and on the right we have -1 plus 2y. Now that's what x is. We'll now take that and substitute it into the other equation. There's the other equation. Since x equals -1 plus 2y, let's put that where the x is in the other equation. 3y equals, substitute in, -1 plus 2y, and then plus 4. Now we'll solve this equation for y. We have like terms on the right. -1 plus 4 is 3. So that becomes a 3 plus 2y. Now get the y's together. Let's move them to the left. Subtract 2y from each side. On the left, 3y minus 2y is y. And on the right, we have 3. So y is 3. Next, substitute that into any of the equations. And remember, the easiest one is the one we solved for at the very beginning, which is x equals -1 plus 2y. Since y is 3, we'll substitute 3 in where the y is. Multiply first. 2 times 3 is 6. And -1 plus 6 is 5. So x is 5. Now let's write the final answer. X is 5 and y is 3. That's like two lines that intersect at the point 5, 3. Number 5. X minus 4y equals 1 and 2x minus 8y equals 2. To solve by substitution, start by having a variable with coefficient 1. And that's the x in the first equation. That's the only choice we have. Let's solve that equation for x. Since 4y is being subtracted, let's do the opposite and add 4y to each side. 4y cancels on the left, and we have 1 plus 4y on the right. Now let's substitute that into the other equation. Since x equals 1 plus 4y, that's what we'll write in place of the x. We're going to substitute in 2 times. For the x, we're going to substitute 1 plus 4y minus 8y equals 2. Now let's solve that equation for y. We can distribute there. 2 times 1 is 2. 2 times 4y is 8y. Minus 8y equals 2. We have like terms. There's y's on the left that can go together. 8y minus 8y is 0, so they cancel out, which leaves 2 equals 2. Now this is one of those situations where the variables canceled out completely. So now we have to ask ourselves, is this a true statement or a false statement? 2 equals 2, that's a true statement. So that means that there are infinitely many solutions. If the remaining statement was false, it would have been no solution. Since it was true, there's infinitely many solutions. This is when two lines overlap each other, becoming the same line. Number 8. X plus y equals 16, and 2y equals negative 2x plus 2. To solve by substitution, start by finding a variable with coefficient 1. We have the x and the y in the first equation, and those are our only choices. So decide which one of those you want to solve for. You could do either one. Let's solve for x. To solve for x, we'll subtract y from each side. Y minus y cancels out on the left, leaving x. And on the right, we have 16 minus y. That's what we'll substitute into the other equation. Since x equals 16 minus y, we'll substitute that in for x in the other equation. Now solve the other equation for y. We can distribute on the right. Negative 2 times 16 is negative 32. Negative 2 times negative y is positive 2y. Watch your minus signs there. And then the plus 2 that was on the outside. I have like terms I can combine. Negative 32 plus 2 is negative 30, so let's simplify the right there. There's y's on both sides. That's a plus 2y on the right. Let's subtract it to move it to the left. Subtract 2y from each side. 2y minus 2y is 0 on the left. 2y minus 2y is 0 on the right, leaving negative 30. Here's another situation where the variables have disappeared and canceled out. Ask yourself, what remains? Is it a true or false statement? 0 equals negative 30 is false. This is no solution. When it's false, it's no solution. This is like two parallel lines that never intersect. And since they never intersect, there's no solution. Substitution can also be used to solve real-world problems involving systems of equations. It may be helpful to use tables, charts, diagrams, or graphs to help you organize the data. Make sure you identify what the variables are that you're using. You solve by substitution in the same manner that we just now solved the last few. Use the question to set up your equations. Number 1. At the end of the 2007-2008 football season, 38 Super Bowl games had been played with the current two football leagues, the American Football Conference and the National Football Conference. The NFC won 2 more games than the AFC. How many games did each conference win? Well, first let's identify the variables here. The variables will be how many games each conference won. So let's have X be the number of NFC wins, and Y will be the number of AFC wins. Now let's set up our system of equations. Look for clues in the question. 38 Super Bowl games were played, so that means each one of those games was won, so the total number of wins will be the NFC wins plus the AFC wins, and that will add up to equal 38. Look at more clues. The NFC won 2 more games than the AFC. Well, that means that X is 2 more than Y, so X equals Y plus 2. That's our system of equations. Now, to solve by substitution, look for a variable with coefficient 1. And they all have a coefficient of 1, so choose one, and it doesn't matter. We'll choose this one, since that one's already solved for itself, so we can save ourselves a little bit of work there. So since that equation is solved for X, let's substitute what it equals into the other equation. Since X equals Y plus 2, let's substitute that in for X in the other equation. So Y plus 2 plus Y equals 38. We just substituted Y plus 2 in for X. Now let's solve that equation for Y. Combine like terms. Y plus Y is 2Y. Subtract 2 from each side. 2Y is 36. Divide by 2, and Y is 18. So the AFC won 18 games. Now let's find X by substituting 18 into either equation, and remember the easiest choice is the one that was already solved for the first variable, and that's your X equals Y plus 2. So substitute 18 in for Y, since Y equals 18. And now work that out, and X equals 20. So the final answer, how many games did each conference win? Well, X is NFC wins, so the NFC won 20 games. And the AFC, that's Y, they won 18 games. Identify the variables, write out your system, substitute, and then make sure you write out your final answer in the context of the question. So when you substitute, start by finding a variable with coefficient 1, solve for that variable. Then substitute that result into the other equation and solve it. At that point, you have a value for one of the variables. Substitute that value into either equation and solve for the other variable. Remember, your answer can be written as an ordered pair, just like a point on the line. If 2 lines intersect, that intersection will be the solution. Remember that if your variables disappear and you're left with a true statement, that's when it's the same line and there's infinitely many solutions. If your variables disappear and it's a false statement, that's no solution, just like parallel lines.